we have seen the coefficient E is caused by the diagonal rods, either continuous rod running from port bow to starboard quarter, जो आपने diagram बनाया था, or divided soft iron which is running from starboard bow to port quarter. These two will produce positive E. The opposite of that will produce negative E. One thing we should be familiar with, that these diagonal rods will be very rare to find on merchant ships. जितने जहाजों में आप गए हैं वहां पे इस तरीके के डायगोनल रॉड्स मिलने थोड़े मुश्किल हैं, बट हो सकता है कि मिल भी जाए। अगर मिल जाए तो क्या करना है, उसकी करेक्शंस कैसे होगी, उसका स्टडी क्या होगा, कैसे व्हाट इज द डिफरेंस ऑफ लैटिट्यूड, उसके ऊपर क्या पड़ता है, फोर्सेस का क्या फर्क पड़ता है, दैट वी शुड understand. As we have already seen in the first class of this, when we were talking about all the coefficients, that coefficient E is also a function of the cos, which is twice the cosine of the cos, जो अपने definition में भी लिखा है. Can somebody read the definition what we wrote?
Yes. The coefficient E is the maximum value of the quadrantal deviation, which varies as the cosine of twice the compass course and is caused by the horizontal field at the compass position due to induced magnetism in horizontal soft iron situated symmetrically about a 45-degree line to the compass position.
Very good. So we have seen that the rods will be at an angle 45 degrees this side or 45 degrees this side. They will produce minus E or plus E, as we have already seen. In case of plus E, there is deviation which is happening again quadrantal it is. That means for 90 degree, there is one type, one sign of the deviation. Next 90 degree, the sign changes. Then opposite quarter will be changing, will be having the same kind of, like east east opposite, west west opposite, and these two will be different for minus E and plus E. जहाँ पे ईस्ट है वहाँ वेस्ट हो जाएगा, जहाँ पे वेस्ट है वहाँ पे ईस्ट हो जाएगा. The diagrams can be made by you. Let us think that you are having the first case, जो आपने पहला continuous rod running from port bow to starboard quarter, इसके लिए एक डायग्राम बनाइए, वही 8 हेडिंग्स पे, cardinal and intercardinal headings, and just try to see that what kind of deviation will be created, what kind of effect you are seeing on the directive force. Please do this exercise. Try doing that. Make those 8 of the headings और उसके ऊपर में port bow to starboard quarter का positive D is what we are talking about. Please check out the result. Are you getting there?
बना रहे
Okay. How did it come? Can you tell me the summary? North heading पे क्या हो रहा है?
नॉर्थ में जो सॉफ्ट आयरन है उसमें फॉरवर्ड पे रेड होगा, और ब्लू हाफ में जो स्टारबोर्ड क्वार्टर पे है उसमें ब्लू होगा, तो रेड रेड विल अपोज ईच अदर, तो
Deviation.
ईस्ट
Very good.
और करेक्टिव
EF.
फोर्स सर रिड्यूस हो जाएगा, डीएफ।
Great. Great. What happens when at 45 degrees? 045. जो रॉड ऐसे थी 45 डिग्री पे जाएंगे तो सीधी हो जाएगी कि नहीं? नॉर्थ साउथ में आ जाएगा। जहाज ऐसे होगा 45 डिग्री पे, बट जो उसका रॉड तिरछा था वो सीधा हो जाएगा या नहीं?
यस सर।
So, जब सीधा हो जाएगा तो डायरेक्टिव फोर्स विल बी मिनिमम, बट डेविएशन कॉज विल बी जीरो, क्योंकि दोनों एक ही लाइन में है, एक ऑपोजिट लाइक दिस। सो इसके बीच में डिफरेंस नहीं है, तो डेविएशन विल बिकम नील, द डायरेक्टिव फोर्स विल बी मिनिमम। सही है तरुण? तरुण सर?
यस सर, गॉट इट सर।
पकड़ में आ रही है ना बात? कीबोर्ड पे करें?
नहीं सर, समझ गए सर।
Okay. So this can be, done for all the 8 courses that we are doing for all the coefficients, cardinal courses and intercardinal courses, in between the two, north, south, east, west, और उसके बीच में north east, south east, साउथ वेस्ट एंड नॉर्थ वेस्ट, चारों के ऊपर हम करके देखेंगे। तो देखेंगे कि 90 डिग्री में चेंज होता है, द डेविएशन साइन चेंजेस आफ्टर 90 डिग्री 90 डिग्री। सो now what is the effect of latitude and course on coefficient d? As we said earlier, okay, बोर्ड पे चलते हैं, थोड़ा सा लिखना पड़ेगा। So as we have already seen, again these are horizontal rods. Although 45 degrees angle पे है, but these are horizontal rods and induced by H. So when we go at the equator, H is maximum. When H is maximum, the induction will be maximum. When we go up, H is less, induction will be less. That means this D is independent of the, the dependence of deviation is independent of the latitude. मतलब latitude पे change नहीं होता है, it remains same all across. है तो जितना है उतना ही रहेगा for all the latitudes. When we go to the pole, H is finished, this is also finished. So compass is non-functional basically. There is no directive force. तो compass का ये देखेगा किधर, needle किधर को देखेगा? There is no H. So coefficient E also is independent of latitude. But what is the effect of courses? As we have seen, coefficient E is equal to, इसका मीन वैल्यू कैसे निकालेंगे? तो on north minus on easterly course plus on south minus on west divided by एवरेज आउट निकालते हैं इसका। कोएफिशिएंट ई की वैल्यू पता करने के लिए डेविएशन नॉर्थ में कितना, ईस्ट में कितना, साउथ में कितना, वेस्ट में कितना, बाय दिस we take out the value of E, and so deviation due to E will be, okay, similarly on different places, delta 2 by delta 1 is equal to cos 2 from cos 2 by cos 2 from cos 1।
सर कैमरा एडजस्ट करने से नीचे का दिख नहीं रहा।
नीचे का नहीं दिख रहा। नाउ हाउ इज इट?
ठीक है सर।
ओके, तो लैटिट्यूड का कोई असर नहीं है इसके ऊपर। कोर्स के बारे में हमने देख लिया कि इट इज डिपेंडेंट, इट इज द वैल्यू ऑफ डेल्टा इज मैक्सिमम वैल्यू मल्टीप्लाइड बाय cos 2 comp कोर्स। कॉम्प कोर्स मतलब कंपास कोर्स। नोटेड डाउन? As we have already seen and discussed that the coefficient E is hardly present on any merchant ship, so you will not have this. But just in case, if you have this coefficient E, let us say plus E you have. In this case, you need to create a minus E, opposite and equal, by another soft iron. This can also be done by the same sphere this can be done in the similar fashion. That means we have the spheres which are placed at 45 degrees to the compass. Let us take first case plus E ka, जिसमें we had the compass was like this. The rod, a continuous rod running from port to quarter, port to starboard, port bow to quarter, starboard quarter. Against this, we have to create another one. So what we do, correction will be done by placing the soft iron like this. Red pen किधर गया? Like this. This is for positive E. Another case of positive E was also like this. Divided soft iron running from starboard bow to port quarter. In this case, the correction can be done the similar way by placing the soft iron in this manner. If this is positive E, this is going to create minus E. Similarly, if it is minus E, होना तो नहीं चाहिए, but अगर है, तो we have to create a plus E for that. And how we are going to do that? इसके opposite में, this will be now minus will be like this, and now this is minus. So इसके लिए उल्टा करेंगे. This will go to this side, this will go to this side. So by the soft iron, we can have the correction of D and we can have correction of E. We have already seen that D was created by athwartship rods. So we were keeping the soft iron like this, aligned athwartship. But in this case, we can have aligned it 45 degree to the center line running for forward and aft. However, the smart way of correcting the D and E together is just by one set of spheres. We have the compass here, we have the soft iron spheres. So this we do the correction for D, जो इसके पहले देखा था हमने, and then it is slewed a little bit this way or this way at an angle. इसको थोड़ा सा slew कर देते हैं so that it also takes care of E. This will be shifted little bit, maybe to like this and to like this. So by slewing it, so which side it will be slewed? How much from here to here? If the angle of slew is, let us say, m degree, then tan 2m is equal to E by D. क्योंकि एक कंपोनेंट ये है, एक कंपोनेंट ये है, तो definitely we will take the tan of this to get that angle. So this is in general what is not paying too much attention here, क्योंकि ज़्यादा होता भी नहीं है ये, less chances of this being available. So we have seen so far all the horizontal rods, the force P and Q, the rods which are producing A, B, C, D, E. What happens when the shape is not like this, but say is heel to one side? The compass was here, the compass is here now. If we take a look at this condition, and if there was a rod at the bottom of the compass, the red end is, let us say, on top here. It can be blue also, depending on, this is of course magnetized by Z. Vertical rod below the compass. Depending on the hemisphere we are in, this can be blue or this can be red. This is placed on a gimbal. Rings are there, जिसमें ये टंगा रहता है. So right now this is producing one kind of effect. But when it is listing to one side, this will become, the compass will become horizontal once again because of the gimbals. Is that correct or not? Earlier
Yes.
it was in the same line, but now it is going to the starboard of this or not?
Yes.
So this is going to create a deviation, what we are going to call healing error. अभी तक जितने रॉड्स देखे थे, that was, we were studying when the ship was upright. जो भी सारे फोटोज हमने बनाए, जितने डायग्राम्स बनाए, that was considered that considering that the ship was upright all the time. The horizontal rods, this rod, that rod, everything that we talked about, A, B, C, D, E, all considering that the ship is upright. But when the ship is heel to one side, this is what we are going to have. There will be an error once again. So let us see top rod. Actually ऐसा नहीं होगा, ये सेंटर इसका हमने गलत बनाया. This will go something like this. Because when it is going like this, the compass pole will shift to the other side. Correct? It will shift to the other side. So the compass center has gone here. So when it is starboard heel, the pole goes to the opposite side. Port. Similarly, when the ship is heel to the port side, the rod will go to the other side. So starboard में पोर्ट की तरफ शिफ्ट होएगा और पोर्ट हिल में starboard की तरफ rod shift हो जाएगा. And you can understand what is the situation. Let us say that this end was like this. The component R that we had, PQR, R को compensate करने के लिए क्या था हमारे पास? we had vertical permanent magnets. Is that correct? Correcting magnets.
Yes, sir.
Okay. So it is something similar, that is just one. So there will be few conditions that we need to talk about in this. What is happening? One by one, we will take this understanding. So first of all, write down the definition of healing error. Please write down. Healing error. Remember that we are not calling it deviation here. We are not calling it deviation here. Deviation already happened because of A, B, C, D. इसके चलते डेविएशन हो चुका है, बट उसमें अगर जहाज लिस्टिंग होती है, हील होता है, तो डेविएशन चेंज हो जाता है. लेट अस से इफ इट वाज 5 डिग्रीज, लिस्ट के साथ थोड़ा 5 का 5.5 हो गया, तो देयर इज एन एरर इन द डेविएशन, and that is why we are calling this particular topic as healing error, not as healing deviation, but healing error. So definition: healing error is the difference in deviation healing error is the difference in deviation between that that when the ship is upright, and that when heeled on the same course. So ship was going like this, the deviation was delta. If she is heeling to one side, this becomes plus or becomes minus x. The difference of this is going to be the healing error. So continue writing just to clarify the point. For example, if the deviation was 5 degree east, if the deviation was 5 degree east, when upright, the deviation was 5 degree east when upright, and 7 degrees when heeled, and 7 degrees east when heeled, the healing error is 2 degrees east. Understood? Clear? Now the main reason, as we have discussed, that what is the cause of this, that when the ship is upright, the lines of forces because of the rod below is symmetrical and passing like this. When the ship is heeled to one side, for example, because of this, it goes away. Now it starts working in this direction because the rod is still like this. So the lines of forces due to rod is working at oblique angle. So this causes a different kind of situation for the compass, and compass will swing to one side depending on the polarity and the heel, which side it has gone. This can either be red or it can be blue, and it can either be heel to starboard side or it can be heel to port side. So in all these cases, the deviations will be different. So what we call the angle of heel. Suppose the ship is heel to one side, which is the port side. The forward of or the center line through the ship is like this, and the vertical is this. So this angle is angle of heel. Denoted by small letter I. This is the vertical running, and this is the ship's vertical line. Remember that when the rod is here, she will maintain its orientation like this, but because of the gravity, the compass will have shifted from here to here. So is this the port heel that we are seeing? Is it the port heel?
क्यों नहीं देखते उन्हें कड्डे ही है जो बस मैं के भाई बाथरूम करा ला अंदर चाचा किवें तू फिर करता ना अंदर ही इधर आई अल्लाह
Karanji, your mic is on.
ओके
Okay. Yeah. So this is what we have is the port heel. In this case, for example, because of port heel, if this was the red end, which side has it shifted to?
What's up?
Yes, sir. Yes, starboard. So the pole has shifted to starboard. Similarly, when the ship is heeled to this side, the forward or the center line, vertical center line will be like this. The rod will still be in the same condition. The red end, let us say here. In this case, this has shifted, the compass because of gravity has shifted to this side. So starboard heel, the shifting of the pole is to the pole. This is the angle of heel. So when this is the case, or let us say this one, this is the case. Carry to starboard. Now, can you tell me what kind of deviation it will cause?
So westerly.
Westerly, yes. This will cause westerly deviation because it has gone to this side. So the front end will be pushed to the other side. If blue end, so it will attract here, which is the aft end of the compass. If red end, then it will push the red end to the western side. So westerly deviation, this is going to cause. This is, of course, going to cause easterly deviation. That is when the poles are like this. But if the pole is ulta, blue pole here, the red pole here, what will be the effect?
So easterly on top, on the port hill and western.
Exactly. When port heel is there, it will give easterly deviation. When starboard heel, it will give westerly deviation. दोनों opposite होगा एक दूसरे का. So why it can happen? एक तो healing तो होनी है, but when it is healed, what is actually changing is the force R is which was running vertical, which was the vertical component, is now at an angle because of the heel. It is an angle. So R is one cause of the healing error. Second cause is induced healing error. So एक तो fixed है the vertical component of the permanent magnetism R, which is going to cause this deviation. Other one is induced healing error. So this can happen. The induced healing error can happen for in various rods. It can happen due to K rod. So K rod healing error, we can say. It can happen because of E rod. It can happen because of G rod. Can happen also because of C rod. But these two have very mild effect, maybe, I mean, which can be neglected. More prominent will be this and the R component. So if we say, what is this K rod? It is the rod below the compass, the vertical rod below the compass. What is E rod? If we had the ship like this, a continuous running athwartship rod. If this, then we have compass here, a horizontal rod below the compass and forward of the compass aligned forward up. Or it can be vertical rods also. The C rods, the vertical rods are something like this. Because when the ship is hilling to one side, the poles will shift away either to this side or to that side. Compass will swing because it is on the gimbals. So when it is going, this goes to the other side, this shifts away. So the main causes, the force R because of the permanent magnetism, then induced healing error because of all these conditions. G and C rod will have quite less amount of effect on this, but major effect will be because of K rod and E rod. Since it is symmetrical, once it is shifting, it will go closer to one end of the rod here. If it is coming like this right now, of course, it won't be magnetized here, but going east-west, this will be magnetized. Are we good?
Yes.
All right. All right. Go on to self-study for 5 minutes. I'm getting back. Just 1 second. वैसे time तो हो ही गया. Another 10 minutes to go. You can take this 10 minutes for self-study. Go through your notes and materials, and we can sign off in 10 minutes. Remain logged in. We'll take a look. We will have one more class on the remaining part of it, जहाँ पे इन सब टेक्निकल चीजों से हट करके more to the ground, more closer to the practical life. What are the practices to follow when swinging the ship or compass adjustment and things like that? We'll talk about.